We're going to continue Unit 5, Introduction to Functions, with Lessons 5 and 6, Function Notation to describe rules and features of graphs. You'll find the material in your student workbook. Lesson 5 is covered on pages 46 through 51. Lesson 6 is covered on pages 57 through 63. You're responsible for going into the summary for both Lesson 5 and Lesson 6 and highlighting important vocabulary, going over the samples, taking notes, and letting it sink in, coming back to class with any questions that you might have. Start with the warm-up. The warm-up is on page 46, and we're going to be looking at the equation Q equal 4 plus 0.8p. I want you to take some time to explain or show your reasoning. Question number 1 asks what value of Q would make the equation true when A, P is 7, and B, P is 100. Question 2 asks what value of P would make the equation true when Q is 12 and when Q is 60. So pause the video now, do the work, come back and compare answers. Make sure that you're showing your work in your workbook. For part A, we know what P is, so we're going to take 7 and we're going to replace it with P in this expression to find Q. So 4 plus 0.8p, P is going to be replaced with 7. Use your calculator to simplify. Use your order of operations. Perform the multiplication first. 8 times 7 is 56. 8/10 times 7 is 5.6. And then add that to 4. Do the addition last. You should have gotten P is equal to 9.6. Now substitute in 100 for P. 100 times 8/10, and then add that to 4. Show your work in your workbook. I'm not showing all the work completely. All right, you should have gotten 84. Again, 0.8 times 100 is 80, and then 80 plus 4 is 84. All right, now let's move to question number 2. What value of P would make the equation true when Q is 12? All right, so now we're going to put in 12 for Q. So we're going to start with the answer. 12 is equal to 4 plus 0.8p. All right, undo the operations around P. So we're going to start by subtracting 4 from both sides. Again, show all your work in your workbook. I will be checking your workbook sometime this week, probably more toward the end of the week. 12 minus 4 is 8. Bring down the equal. 4 minus 4 is 0. Bring down the 0.8, P. And then to finally solve for P, you're going to divide both sides by 0.8. So what is 8 divided by 0.8? The answer is 10. All right, so let's go ahead and continue with part B. Q, this time the answer, we're going to replace the Q with 60. So 60 is equal to 4 plus 0.8p. Okay, you're going to follow the same steps, show your work. You should have gotten P is equal to 70. All right, make sure that you are practicing, asking questions, coming to me if you see any mistakes, because we will be building on each of these skills. All right, now turn to page 47, and we're going to complete activity 1. A college student is choosing between 2 data plans for her new cell phone. Both plans include an allowance of 2 gigabytes of data per month. The monthly cost of each option can be seen as a function and represented with an equation. So option A of x equals 60. And then option B of x equals 10x plus 25. In each function, the input x represents the gigabytes of data used over the monthly allowance. For part 1, the student decides to find the values of A of 1 and B of 1 and compare them. What are those values? All right, so we're going to have the input of 1. X is the input. So for the first function, there's nothing on the right-hand side but 60. So no matter what you input for X could be 100, you're still going to pay a flat rate of 60. For option B, if we input 1, multiply, we do have a place to substitute the 1 in for X. It's going to be right here. 10 times 1 is 10, plus 25 is 35. All right, so we're putting in 1. What does that represent? Okay, that's going to be gigabytes over 2, I believe. So don't just get an answer, pay attention to the question. A of 1 is 60, B of 1 is 35. Now, after looking at some of her past phone bills, she decides to compare A of 7.5 and B of 7.5. So we're going to do the same thing, but instead of replacing or substituting in 1 for X, we're going to substitute in 7.5. Okay, now option A is going to stay 60, but option B is going to be 7.5 times 10, which is 75, plus 25. Your answer would be 100. All right, so for option A, we're still going to pay $60, and option B, we're going to pay $100. Now describe each data plan in words. So we're going to go back to the words up here, the math that we've been doing, and we're going to put it all together. Option A charges a flat fee of $60 each month. It doesn't matter how many gigabytes you use. Option B charges $25 each month. So let's go back up here, $25 plus $10 for each gigabyte over the 2 gigabytes. Now we're going to graph these functions on the same coordinate plane. Take a minute to see if you can go back to what we just did and graph them. All right, let's look at option B. Option B was the easiest one for me to graph because it's going to be $60 each month. So it's going to start at 60, and no matter how far up we go, for the, I'm sorry, I'm looking at I said months, but we're looking at the x-axis is gigabytes over that 2. Okay, so it's going to be $60 no matter what. So for option B, okay, let's go back and look and see what option B was. Option B is going to start at 25, and for each additional gigabyte over 2, it's going to be 10 times that amount. All right, so we're going to start at 25, and then at 7.5, it's going to go up to 100. We just calculated that. Let's go back here and look at that. Right here. So we're plotting these 2 points, 7.5, 100. We can write this answer like this. Your input is always going to be your X. Your output is always going to be your Y. Okay, same thing here. We can plot the points 7.5 and 60. And these are 2 separate lines. Okay, we can plot 160 and 135. We also plotted, we also found A of 7.5 and B of 7.5. So we have these 2 points here. We've got 160 and 7.560 for function A. We've got 135 right here and 7.5, 100. So that's the points that we're plotting. Okay. And this is going to, if we connect those two dots, it's going to make this line here. All right, now we have to explain which plan you think that she should use. Now she should use option A if she plans on using around 7.5 gigabytes a month. Because look what happens at 7.5. Okay, option A is a lot cheaper. She should use option A if she uses more than 5.5 gigabytes per month. But it also, it's going to be cheaper if we go over 5.5 gigabytes per month or more than 3.5 gigabytes, because we're going to subtract those two that we get. Okay, and she should use B if she uses only about 2 gigabytes per month. Okay, so different ways to word it. What is it that you see? Okay, now they're the same when she uses over 3.5 gigabytes per month. Now let's get ready for activity 2. We have b of x equals 10x plus 25. How would you go about finding the value of b of 1.482? So what you do is you're going to substitute x. The input is going to be 1.482. You're going to put that in here, multiply by 10. So it's going to be 14.82 plus 25. How would you find the value of x that makes b of x 103.75? So this time, they didn't give you the input. Input's going to be what's in parentheses. That's going to be your x. If they give you this number in parentheses, you put it into the equation or the function, and you simplify. If they say b of x equal, they're giving you the y value. So we're going to put that here, and then we're going to solve for x. So talk about what is given and what you're finding. So understand that before we move on. For activity 2, function notation and graphing, this is on page 49. Okay, function b is defined by the equation b of x equals 10x plus 25. Use Desmos, use your graphing technology to find the value of each expression. So let's look at this. Okay, we have the value in parentheses. So we have the x. So you're going to take the 6 and you're going to plug it into this expression here. 6 times 10 is 60 plus 25. What answer do you get? What's 60 plus 25? That answer is 85. You're going to do the same thing for b. You have what's in the parentheses, so that goes in for x. That's your input. Use Desmos to find your answer. Okay, so we're going to substitute in 2.75, multiply it times 10, so that's 27.5 plus 25 is 52.5. Now one way we can write that is the input or the x value, we can write it as a coordinate pair, is 2.75, and the output or your y value is 52.5. So there's two ways to write the answers. Think about that, ask questions if you need to. All right, we're going to do the same thing for C. Use Desmos to put this number into the expression. Multiply 10 times 1.482 and then add to 25, and you should get 39.82. And then lastly, substitute negative 3.5 in for x, then add to 25, and you should get negative 10. Let me know if your answers differ from mine. All right, now we're given b of x, so we're given the answer. So we're going to replace 93 with b of x and solve for x. Pause the video. Okay, replace each of these, b of x, replace it with the answer, and then solve for x. All right, so for a, you're going to replace b of x with 93. 93 equals 10x plus 25. Subtract 25 from both sides, and you'll get 68 on the left, and then 10x on the right. Divide both sides by 10, and you get x equals 6.8. All right, follow that example. Show your work in your workbook when you have the answer 42.1, or b of x. b of x is our y. Then solving for x, you'll get x is equal to 1.71. All right, so for part C, you're going to replace b of x with negative 78. Solve for x, and you should have gotten negative 10.3. For D, again, this goes into the function where you see b of x, so it's going to be substituted here. Write that down in your workbook, show your steps, pause the video, and then check your answer. The answer I got was 9.125. All right, go to the student lesson summary and glossary on pages 50 through 51, and then highlight the vocabulary. Really take some time to read that and understand what each word means. We're talking about linear functions. Linear functions are graphs of lines. Make sure that you're doing the cool down for both lessons 5 and lesson 6 before you leave class. All right, now go ahead and turn to page 57 and start on the bridge for lesson 6. We have the graph that shows the temperature in Diego's house between noon and midnight. So 0 is going to be noon, and then 12 is going to be midnight. Select all the true statements. All right, hopefully you had some time to do this. Pause the video and come back. Let's look at statement A. Is time a function of temperature? Think about what we did on Monday and Tuesday. We said that y is a function of x. So that would be temperature is a function of time. We always start with the output, or the y. So this is incorrect. Let's go to B. The lowest temperature occurred between 4 and 5. So let's look at the interval between 4 and 5. So this doesn't look like the lowest temperature. And 5, we still don't have the lowest temperature. The lowest temperature is between 10 and 11. So that's incorrect. Okay, part C, the temperature was increasing between 9 and 10. So let me look at 9 and 10. So that's the interval here. It looks like it's going down or decreasing, so that's incorrect. The temperature was 74 degrees twice during the 12-hour period. So let me go up on the y-axis to 74. It's about right here, and go across, and let me see how many times I intersect. And that's not a real straight line, but you get the idea. The temperature was 74 degrees twice. So if I draw that straight line across, it's only going to intersect 2 times. So this is true. And down to part E, there was a 4-hour period during which the temperature did not change. So this is where the temperature is flat. So let's see how many hours transpire between 5 and 9. 1, 2, 3, 4. So that is correct. Okay, so the answer, the solution, D and E. All right, now move on to the warm-up on page 58. Pause the video after I've read the instructions, do this on your own, and then come back. Noah and a sibling are going to make their favorite dinner. To find the ingredients, they take a Lyft ride from their home to Rosa Parks Farmers Market. Now this graph represents function D, which gives us distance from the farmer's market in miles. M is our variables for minutes since leaving his home. D is miles, M is minutes. So let's look at our graph. The distance is miles. That's our y-axis. That's D. And then minutes is time. Time is going to be on our x-axis. So what is D of 0? When x is 0, what is the answer? So we're going to go here on the x-axis to 0, and then go up and see that y is 4. What is D of 12? So again, we're going to start on the x-axis, go to 12, then go up to the y-axis. When x is 12, y is what? Y is 1. All right, go down to 3. Now we don't have the input, we have the output. Input is always the x, it goes inside the value, inside the parentheses. All right, so now we have d of m, so we have our y. So 2.4, let's go to the y, let's go to 2.4, right here, and then move over, and our x value, go down, is 5. Okay, but if I stop right there, which is a common mistake, it stays flat. So it stays 5 until we get to 7, and then it starts decreasing. So the interval from 5 to 7 is written like this. 5 less than or equal to m, because m is what we're using for time, less than or equal to 7. Pay close attention to this, and in fact, write it down and highlight it. When you have an interval where a value stays constant, you need to write it this way. All right, part 4, the value of m when d of m equals 0. So again, remember, this is our y value. So let's look at our y value. Where is y equal to 0? Not x, but y. So let's go over here. Y is 0 right here. Go across and tell me what x is. When y is 0 on the vertical axis, x is 17. Activity 1 on page 59, we have a toy rocket and a drone. Now the question or the problem states that a toy rocket and a drone were launched at the same time. So we're going to start at the time of 0 where they're both launched. So we can see that this curve it goes up and it goes down. It represents one of those, either the drone or the rocket. Now I'm looking at the R, so I'm thinking that this is the rocket and D is the drone. Okay, so the rocket's going to start at about 25 meters. The drone is going to start at 0. It looks like the rocket goes up, it hits a maximum at 45, and then it starts going back down again. Okay, the drone starts at 0. It increases until about 2 seconds, and then it hovers at the same distance above the ground until 5 seconds, and then it starts dropping back down. So what are some mathematical questions you could ask about this situation? Go ahead and jot some down. Pause your video before moving on to the next section. All right, we're going to analyze the graph and describe it as precisely as you can. What is happening with each object? Did you get something like this? The toy rocket was launched from 25 meters above the ground. It reached a maximum of 45 meters. It went up quickly, but then it slowed down and it stopped getting higher at that height. And then it dropped back down and hit the ground at 0. Okay. And that was the maximum was at about 2 seconds. It hit the ground at about 5 seconds. All right, now if we look at the drone took off. It went up at a constant speed for 2 seconds, and then it hovered for about 3 seconds, 2, 3, 4, 5, and then it dropped back down, descending at a constant speed until it landed on the ground 7 seconds after launch. A little after 4 seconds, the drone and toy rocket were at the same height. Did I say that right? A little after 4 seconds, the drone and the rocket were at the same height. So you see that intersection. Which part or features of the graph show important information about each object's movement? List the features or mark them. So I want you to take some time to write down what we just did if you haven't already. and then mark them on this graph. Okay, the points where the graphs begin, that's an important feature. Right here for the drone, right here, 0 for the drone, 25 feet for the rocket. The points where the graphs cross the horizontal axis, so where they touch the x-axis. X-axis is horizontal. That's going to be at 0, 50, and 7. Right here, I said 50, 0, 5, and 7. Okay. The point where the graphs change direction. Let me just take this off so we can see it all. Okay, the points where the graphs change direction. Right up here at the top, reaches its maximum, and then it changes direction. For the rocket, for the drone, it's going to change direction when it gets to 2 seconds and at 5 seconds. The shape of each graph, curved or straight. The rocket is curved and the drone is straight. The intervals when the graphs behave certain ways. So we have an interval here, if this green circle, where it's increasing at a constant rate, and then it stays at the same height, and then it decreases at a constant rate. The parts highlighted in the graph. Okay, anything else that you need to highlight, go ahead and do that, but make sure you understand how to talk about what's happening with the drone and the rocket. All right, let's go to activity 2. We have a bungee jump. The height of the jumper is a function of time since the jump begins. Function h defines the height in meters. So look at the y-axis. The height is going to be on the y, and the time is always going to be on the x-axis, and we're measuring in seconds. So here's a graph of function h followed by 5 expressions or equations and 5 graphical features. H of 0, what does that mean? That means the answer, what is y when x is 0? So h of 0 is, I think it's 80. Look in your book to make sure that you see it carefully. H of t equals 0. H of 4 is going to be our minimum. H of t equals 80. So where y is 80 is where that bungee jumper begins. And then h of t equals 45. So I've just gone through this quickly. We're going to continue looking at this, and we're going to fill in this table. We're going to match each description of the jump to a corresponding expression or equation and to a feature on the graph. So turn in your book to page 60, and you can turn back and forth if you need to see the graph. I put it over here. Make sure that you are following along and writing in your book. The greatest height that the jumper is from the river. What expression or equation was that? The greatest height is h of t. H of t is going to be your y, your output. The feature of the graph is our maximum. Okay, know what that vocabulary word is. The height from which the jumper was jumping. So how do we write that in function notation? We write that as h of 0. When x is 0, okay, when the jumper starts, that's h of 0. That's going to be the vertical intercept or the y-intercept. The time at which the jumper reached the highest point after the first bounce. So you're looking at the max, you're starting at here, you're dropping down, okay? That first peak is going to be h of t equals 45. So the output is 45, and that's going to be at about how many seconds? At about 8 seconds. That's the first peak in the graph. All right, the lowest point that the jumper reached in the entire jump is going to be at about 4 seconds. So that's going to be h of 4. That's going to be the first dip in the graph. Now, something that we can't see is the time at which the jumper hits the surface of the river, or when he gets to 0. That doesn't happen in the graph. Okay, so h of t equals 0. I do not see an answer or a y of 0. Okay, that is going to be our our x-intercept, our horizontal intercept. So we don't have this. That's why I've put it all in purple. So highlight that in your book and note that we don't have a horizontal intercept. We have a y-intercept or a vertical intercept. All right, so identify the following features in the graph. The vertical intercept, that's going to be your y-intercept. The horizontal intercept is your x-intercept. We don't have one. The maximum is going to be the highest point. The minimum is going to be the lowest point. The intervals where the function is increasing is going to be between 0 and about 28. No, I'm sorry, 38, closer to 40. Then it decreases. Then it starts increasing between 50 and 60. So we have two places where it increases, between 0 and about 38 and between 45 and 60. The intervals where the function is decreasing, between 48 and 50, and I don't see it decreasing after that. Let me know if I missed anything. The intervals where the function is staying constant is between 60 and 160, and the value of t when b of t equals 3.5. So think about what that means. We don't know the x, we know the y. This time we know the y. So 3.5 go across would be about 18 seconds. And then d of t equals 3.5. So we're going to look at the y, see where we get to a height of 3.5, go down to your x, and that's going to be about 50. So learn how to look at the graph and how to read function notation. Go through the summary and glossary, go through this on your own. Look at the examples, highlight what is important, and make sure that you're going back over what we did in the lesson so that you can learn it and we can build on it and move forward. All right, we have important vocabulary: vertical intercept, maximum, horizontal intercept, minimum, decreasing, increasing. Go over that function notation. Make sure that you're looking at the pictures, understanding vocabulary. Again, decreasing, how to write that. How to write that using greater than, less than symbols. Make sure you're doing the cool down for lesson 6. Do those before you leave class and complete the practice on page 52. Starting on page 52. Do questions 2, 3, and 4. All right, and then also do the practice starting on page 64, questions 1, 2, 3, and 4. All right, go ahead and use the rest of the class period to work on this, and then turn your answers in through Canvas. Come up to me if you need help, or work with the people in your group to get this done.